Alright, I'm going to work problem 432 in Giancoli. Here we have a pair of fuzzy dice hanging by a string from the mirror. I'm not a fan that they drew the force diagram for you here, but it's one of these where it looks like there should maybe be more forces than there are. But one important thing in the force diagram here, where we know that the only two forces are tension, and weight, if I can draw it in a straight line. The tension and the weight. There's an angle theta here. We know that these are the only two forces, but what's important is that we see that the vertical component of the tension is going to balance the mg, because it's not accelerating vertically. It's only accelerating horizontally. So when I break this into components, that's going to tell me how to set up my F-net equations. So this is the angle that is closest to the component closest to the angle, so it's the cosine. This one's opposite the angle, so it's the sine component. I'm going to call up and right positive. I'm going to write my F-net equations. So it's t sine theta here, and in the y dimension it's t cosine theta minus mg. And because the acceleration is to the right, I know that the vertical components balance and the horizontal components don't, and Newton's second law tells me that equals to ma. Now at this point I haven't even really looked at the rest of the question. All I've done is look at the situation, draw my diagram, and then immediately written my F-net equations. So we're accelerating here, and we want to know what the theta is. So they give us some info about the acceleration. The VI is 0. The VF is 28 meters per second, which is pretty fast. That's like 60 miles an hour. We don't know the delta x, but we know the delta t is 6 seconds. We know the acceleration is this way, but we don't know what it is. So this is an interesting relationship here between forces and acceleration. So what we're going to do is come up with an expression for the acceleration from kinematics, and then use that inside our force equation. So I know VI, VF, and delta t, and I'm trying to find A, so I'm just going to use this one that's derived from the definition of acceleration. VI is 0, so the acceleration is Vf over delta t in this particular case. I'm not going to plug numbers in here. I'm going to use that expression up here. Okay, so I'm substituting into that first F-net equation. And everything's good to solve for theta except for I don't know t, so I'm going to use that equation there. And t cosine theta is mg. So t is mg over cosine theta. I'm going to substitute it in over here. So I have mg sine theta over cosine theta equals mbf over delta t. So I can simplify here. I can lose the m's. So this means that the angle at the fuzzy dice, at which the fuzzy dice hang, is independent of what the mass of the fuzzy dice is, which is kind of an interesting scenario. Simplify that to tangent. So g tan theta is Vf over delta t. Tan theta is therefore Vf over g delta t. And theta is the inverse tangent of Vf over g times delta t. And I know all those numbers, so Vf is 28 meters per second. G is 10 meters per second squared. T is 6 seconds. And theta is about 25 degrees from the vertical.